Okay, so what we've talked about the last 2 days. Last time we talked about inscribed angles and how they relate to their intercepted arcs. The day before that, we talked about central angles and their corresponding minor arcs. We'll do a quick review of those relationships here in a minute. But our objective for today is to look at a couple other angle relationships that we have in circles. More specifically, what we're going to be looking at is when two lines intersect either inside the circle or outside the circle and how those relationships work. What I want to do first, though, is just kind of think back about the relationships we've looked at so far. So 2 lessons ago, we talked about central angles and their minor arcs. How do the measures of central angles relate to the corresponding arcs? Justin? No, I'm talking about the relationship between a central angle and its corresponding minor arc. How do their measures relate? No. Central angle and its corresponding minor arc. How do those relate? They're the same. The measures are the same. Then last class you looked at an inscribed angle, so that's where the vertex is on the circle. How does the measure of an inscribed angle relate to its intercepted arc? Jackson. Inscribed angle compared to its intercepted arc. Of the arc is twice the measure of the angle. Expect questions just like that on your test for this unit. Just like that. Going to need to describe these relationships in complete sentences. All right, the first new relationship that we are going to look at is going to be this situation. We have a tangent to the circle. So if you look, you have this tangent line, it's intersecting the circle at point A. And then we have a chord in your circle, so chord AB. Notice that chord and the tangent both intersect at point A. The measure of your angle formed, so we have 2 angles formed here by that chord. We have angle 1, which is right here. The measure of that angle is half the measure of its intercepted arc. It is half the measure of the intercepted arc. So the measure of angle 1 is half the measure of arc AB. Same thing for angle 2. Angle 2 is half the measure of arc ACB. Measure of angle 1 is half the measure of arc AB. The measure of angle 2 is half the measure of arc ACB. So if we look at the first example, let's put that into play here. We are looking, kind of going backwards here. We are looking to find the measure of arc ABC. We're looking for the measure of arc ABC. This one's actually not extremely straightforward because we're not even given the measure of the angle that corresponds to. There are several different ways that you can approach this. What's one thing that we know from what we're given? Maddie?
Well, the angle should both equal 180.
Okay, so we didn't mention this, but I'm glad you brought it up. These two angles form what? A straight line. They're a linear pair, so they should add up to 180. So if this angle is 54 degrees, what's the other one? What is it, 126? Okay. So now we know the angle measure that corresponds to the arc we're trying to find. If I know that angle measure, what do I do to find the arc measure? Lauren, what are you doing in your calculator?
I was just seeing how that
Oh, okay. So once we know that angle measure, what are we going to do to find the arc measure? Jessica. Multiply it by 2. Measure of arc ABC. It's 126 degrees times 2, which is 252. Adding in some algebraic expressions this time, our goal is to find the value of x. We are given the angle measure is 8x minus 29. We are given that the measure of arc HJK, take a look at which one that is. Arc HJK is here, is 10x plus 50. So at least in this example, we are given the angle and the corresponding intercepted arc. So now we just have to set up the relationship. Say it with me. The angle is half of the arc. All right. We're going to write it just how we said it. The angle, which is your 8x minus 29, the angle is, in math, what is? Equals 1/2 of the arc. The angle is 1/2 of the arc. From here, we can distribute the 1/2 and solve. Multiply 1/2 by 10x, that's 5x. Multiply 1/2 by 50, that's the 25. And then just solve your equation. Okay, what we are focused on for the rest of this lesson are two lines intersecting somewhere in a circle. If two lines intersect in a circle, there are 3 places where that intersection can happen. The first place that can happen is right on the circle. And this is actually the situation that you looked at last class. This is the inscribed angle and its intercepted arc. So you might want to make a note. This was from last class, just kind of bringing that back. That's your inscribed angle and intercepted arc. Now, the next 2 situations are what we are going to add to that. We can have our 2 lines intersect somewhere inside our circle. Please know that that intersection point is not necessarily the center of that circle. Where they intersect is not necessarily the center of the circle, okay? And then finally, we can have our two lines intersect somewhere outside the circle. Like I mentioned, recall that you know how to find arc measures and angle measures for the first case. That's your inscribed angle, intercepted arc. Now what we're going to do is look at the relationships for the second two. By looking at what happens when your lines intersect inside the circle. Notice what you have in the picture, first of all. We have a few different angles formed by those lines intersecting. I have angle 1 and angle 2. Are those the only two angles in the picture? No. But why are these the only two that are marked? Why are these the only two that are marked? What do you think? Very good. The other two angles are congruent to the two that we have marked. Think back to first week of school. We have vertical angles here. Those are congruent. We have vertical angles here. Those are congruent, okay? So if you know 1 and 2, then you know the other. With that being said, the measure of each of these angles is half of the sum of its intercepted arc and its vertical angles intercepted arc. So grab your highlighter notability. This works really well if we kind of highlight this out. So pick one color. So I'm going to start with angle 1. The measure of angle 1 is equal to its intercepted arc and its vertical angles intercepted arc. So think about its vertical angle is right here, and that intercepted arc is here. So the measure of angle 1 is equal to half of the measure of arc DC plus the measure of arc AB. What we've color coded in my purple, whatever color you chose. We can do a similar thing now for angle 2. So pick a different color for angle 2. The measure of that is half of the measure of arc BC, its intercepted arc, and then its vertical angles intercepted arc. So the measure of angle 2 is equal to 1/2 the measure of arc BC plus the measure of arc AD. So looking at example 1, this is pretty straightforward. We are looking for the measure of angle 1. Notice we are given the measure of that angle's intercepted arc as well as its vertical angles intercepted arc. So we can say that the measure of angle 1 is equal to 1/2 of its intercepted arc, which is 75, plus its vertical angles intercepted arc, which is 25. You're given everything that you need to know here, and then it's just a matter of simplifying this down. So 1/2 of 100 is 50 degrees. Don't forget your degree symbol. All right. Finally, we are looking at when our two lines intersect outside of the circle. I want you to notice a couple of things here with these pictures. Just take a look. Your angle is always outside of the circle, first of all, because your lines are intersecting outside of the circle. Notice that in each of these cases, regardless of exactly where those lines intersect your circle, you have two arcs. You have a bigger arc, and then you have a smaller arc. You have a bigger arc, and then you have a smaller arc. You have a bigger arc, and then you have a smaller arc. Okay? That's how I refer to them, the big one and the small one. All right, what you are going to do to find the measure of this angle is you are going to take half of the difference of the big minus the small. So the measure of your angle is half of the big arc minus the small arc. And that would kind of generalize this for every situation. You could write it specifically for each one if you wanted, but in general, the measure of the angle is half of the big minus the small. If you jump down to the example right below it, you'll see this situation. Your angle is outside of the circle. You have what I refer to as the big arc, and you have what I refer to as the small arc. So to find the measure of that angle, we'll take half of the big minus the small. And then simplify. Don't forget your degree symbol.